Okay. Hi, everybody. It's nice to have everybody here. I'm Corey Starks. I'm associate professor. Do you all see my screen shared?
Yes.
Yes. Okay, great. I'm an associate professor in the Department of Demography, and I've been at UTSA since 2007. And I teach a lot of R classes, very interdisciplinarily across campus. I have a lot of students from a lot of different departments come take classes with me. And last year, we decided as a department to offer this two-day boot camp of sorts to our incoming graduate students. And this year, I decided to open up to the college and other folks that I know around campus, specifically that I knew had grad students that were interested in using R or that I'd had in classes before, et cetera. So we've got an agenda devoted to the next 2 days to learning R from first principles. And so it's really what we're trying to do here is do a short introduction course to the R statistical programming language. Mainly, it's not going to make you an expert in R. I've been using R for 20 years, and I don't consider myself an expert. But it is intended to get you up to speed so that you can at least start trying to use it for things that you care about. Most students coming in haven't had any exposure to R, especially in the social sciences, and R and Python are two of the most in-demand programming languages in all of science these days. So maybe we can do one on Python sometime. What I hope you get from this is you'll get R set up on your personal computer if you want to follow along. So we're going to start with installing R and installing a program called RStudio that we'll use to run R with and get oriented about where things are. Today, we're going to be looking at fundamentals of reading and data. And tomorrow, we're going to be really turning to getting to data visualization and using a suite of packages known as the tidyverse, which is a method of modern literate programming for R. So here's our agenda for day one. Again, we're going to go over what R is. A lot of people have heard about R, but you might not know what it means for you. Snippet on history. We'll install R and RStudio on our computers, introduce sort of the geography of the RStudio interface. We'll take a quick break, and then we'll start reading in data, using R to do some statistical summaries of data, and then we'll have some time at the end for Q&A. Tomorrow, it'll be much more in-depth actual content. We'll be using ggplot package for statistical graphics and dplyr. These are two really in-demand packages in R that a lot of sort of modern data science people use in their daily workflows. And probably about 6 or 7 years ago, I really converted everything that I did over to these suite of modern literate programming and never looked back. We'll talk about our file types and some common packages that you see. And all the while, we'll have time for questions that you might have. And we've got two fantastic pros in the room, Scott Craig and Samson Oluwalaju. These are two, Scott is a 3+ year PhD, and Samson is a 3rd year PhD in our demography program. They'll be keeping an eye on the chat for us, and they're both aces and have used R for a long time. So let's dive right in. So talking about what R is, R was first invented in the early 1990s by Rob Gentleman and Rase Haka. They're both from New Zealand, the University of Auckland. It was really meant to replicate what was something known as this S statistical language, which is very popular around this time of, it was invented in Bell Labs in the 80s. And it was really a powerful suite of software then. R has come to its own in the past 20 years, and the R ecosystem now includes over upwards of 20,000 user contributed packages that do most anything in data analysis, plotting, data management. You can publish websites with it. You can do all of these notes were written in R. So you can do really anything with it. That's why I use it for pretty much everything I do. I've used R for over 20 years now. I was trained in SPSS and SAS, but sort of along the way by various professors. But R really became something I went to for everything that I wanted to do in terms of data analysis, graphics, data management, sometime about 15, 16 years ago. My top 3 reasons for using R, and I think some of the people on the call that have used it before will agree with this. Number 1, it's free. R is 100% free. It always has been. This is great because students are on a budget. You don't have a lot of money to spend on software. Plus, it's localized in a lot of different languages around the world. Your R code can translate into a lot of different languages, and you can work anywhere in the world with people using the same syntax, all for free. Number 2 is really, it's a hotbed of methodological development. So any sort of new statistical routines or data analysis routines that are invented by research statisticians and data people come to R first, okay? Mostly because it's open source, meaning that you can see all the code that generates all of the analysis you're doing all under the hood. You can modify it, you can ask questions about it. It's really quite flexible in what it can do. And so everything that's new in the data analysis world comes here first. So it's very nimble, unlike a lot of commercial packages, which aren't. It has a very supportive community of users. So R has a learning curve, but I think what you'll find, especially in places like Stack Overflow, places like Twitter, there's a very supportive community of users that support R, and they're people like us. They're graduate students, they're professors, they're people that use R in industry. They want to help people learn. And that's kind of what we're here tonight to do. And so I've personally answered lots of questions for people that I've never met before. I've ended up collaborating on papers with people that I met on Twitter using R that had questions and had saw something that I had published before. So it's a really neat group of users that make up the R community. So let's dive right in. So first, we're going to get you all set up with R on your computers. I'm running Windows, so R can be installed on any operating system: Windows, Mac, Linux, even more exotic forms of computer, Solaris, and things like that. There probably aren't many Solaris users on the call, but you never know. So R will come with a base installer package. And then there are other things that we'll be adding to it and installing along the way. So we'll just follow the link here. And let me put this, I'm going to put this file into the chat, the one that I'm looking at right now, so that you can scroll along if you want. So it's just a HTML file. Yeah. To everyone. Okay, so you can open this file that I just put in the chat, and these are the same notes that I'm looking at right now, and all the links work. So the first place you're going to go to get R is this place called CRAN, which is a Comprehensive R Archive Network. This is basically where R curates all the packages that, or most of the packages that are contributed by users, as well as the official installers that they make for the various versions of R. So you can just pick your version of your operating system here. Like again, I said I'm running Windows. You'll install what's known as base R first, which is the fundamental suite of packages that does a lot of core functions in R. Same way, if you're once the installer downloads, you'll launch it, and it will pop up with a little installer. You walk through it, you basically say yes to everything, and it will install on your computer. Same thing, if you're a Mac person, you'll download a disk image file or package file. Same process, installing it on your computer. If you're on a computer that you're not an administrator on, you might have an issue, because R will allow you to install to a different folder, a user folder that you control. But so if you have issues with that, we can talk, and if you can ask a question later. UTSA computers in labs usually require an admin to install things. So just be aware of that. So that's the first thing we're going to do, is you can do that. The next thing that I have you download is this package known as RStudio. It's called RStudio. And this is an integrated development environment for R. So if I just start up R in its vanilla state, it's not very impressive, and it really is not very pretty to look at. Okay, so here's when you first open R up, this is what you see. Basically, you see the R version when it was made, et cetera, but not a lot going on. Okay, this is how R existed before about 2015, when RStudio came along and invented this integrated development environment for the software, which gives you a lot more power to interface with your computer, to see output of what you're doing, as well as do all kinds of wonderful things that you can't do in base R. So you can download this. Again, it will recognize sort of what operating system you're running and download the appropriate version of R, Mac, or PC, or Linux. If you're in Linux, we need to talk, because a lot of stuff with Linux installs you have to do via the command line. So you can download this. And just like the R installer, once it finishes download, you'll run the installer file, and it will install RStudio on your computer. And I highly recommend you installing it in that order. Install R first. Once it's done, then install RStudio, because RStudio is going to be looking for where R is located on your computer. So here is the RStudio installer somewhere. Yeah, so right now I have it currently running, so it doesn't want to install it. But if I didn't have it running, it would walk me through the installation process. Again, say yes to everything, and it'll be fine. If you're a Windows user, I highly recommend that you download one more thing from the R people, and this is called RTools. RTools is a secondary set of software that contains mostly source code compilers, things like Fortran and C++, sort of more high-level programming language. A lot of R packages are actually written using those languages at their source. And to install them and use them, you have to compile them. So you have to build from the code up to an executable file that R can then use. So Windows doesn't come with C++ and Fortran compilers built in, so this is something that installs all the tools that you need to do all that. If you're on a Mac, Mac users will need to make sure that you have Xcode. Xcode is the coding development environment installed if you're going to build a lot of packages from source code. Most packages do not require you to compile them, okay? And all this happens kind of under the hood in an R session. You don't really interact with that at all. Some packages do require you to compile them. And to do that, you'll have to have the right compilers on your computer. Xcode is a little bit of an adventure if you're a Mac user. I think you still have to register with Mac as a developer to get it. Scott, I don't know if you've ever had to install Xcode. No, you've never. Okay. So I used to be a Mac person a long time ago, and I used to have to run Xcode a lot. and it was quite a pain in the neck to use. Okay, so once you run those three things in order, again, Mac users won't do the RTools thing at all. You'll need R and RStudio to kind of follow along with the rest of the boot camp. Okay, any questions before we look at RStudio?
Corey, I have a question.
Sure.
If I've had R and RStudio on my computer for a long time, as you know, but if I'm updating RStudio, do I need to update R first?
Yes, please update R to version 4.2.1 and RStudio to its current version. Okay. And if you had any packages installed, you'll need to reinstall those as well.
Okay.
Any sort of major version of R that comes along, it's like 4.1, 4.2, those are major versions. You'll need to do a reinstall of it. A lot of people don't like that, but it makes sure that everything is, they clean up bugs all the time, they add new features all the time, and certain packages require certain versions of R to even run. So if you have R on your computer and it's like version 4 or version 3.9 or something that's been there for a while, I would uninstall it and then reinstall a fresh install of R.
Okay, thanks.
Yeah, absolutely. Great question. Okay, so now we're going to look at RStudio. And again, this is an open source integrated development environment for R. RStudio, actually, you can use it to write SQL, the database query language. You can use it to write Python. You can use it to write other fun programming languages, C++, if you're into that. So RStudio isn't just about only R code anymore. It sees a lot of data analysis. It's kind of this integrated system of coding. And actually, at the last RStudio user conference, which was about a month ago, they changed the name of RStudio to something called Posit, which is going to be coming out in October, which is going to be more fully integrating R and Python together in future releases. R is not going anywhere. Everything we're doing tonight is not going anywhere. It is going to be just going in the future. It's going to be easier to collaborate across languages. It's a much better interface for using R because not only does it allow you to write code in multiple languages, if that's what you're into, it also allows you to navigate computer files, interact with the file system, see your output, things like that. RStudio has a few different major components of it. When you first launch it, it's going to look something like this. It's going to have several windows at your disposal. Here's mine. Right now I have open a code file that is actually the code that generated the notes that you're looking at. So this is this is something called a Quarto document, which is a new way that to build dynamic documents using R and other things. So this is what I wrote the notes in, but probably won't see that. So inherently what you're seeing, yes, enable transcription, thank you. So basically, this is what the notes window looks like, okay? So you have a code window, a console or an output window. You'll have a window that shows your environment and a window that shows the file system. So I'm just gonna hop over here real quick and go through this. So here is my code window. This is where I would write code to do analysis, et cetera, et cetera. There's a few different types of documents that you can write R, you can write Quarto, Shiny, a C++, all these different types of files that you can write in RStudio. So it's not just about writing R script. It's much bigger than just that. This is where you would write your code to do stuff. On mine, the console's down here. So if I just, let's say I just go up here and I generate a bunch of random data, I'll generate 1,000 random normal deviates, and it shows in the output console that right there. If I just type X again, I can print out the data that I just did, and this is the console is where any code that you run prints out its output. This is the environment window. environment window shows all of the objects that are currently loaded into memory. Whenever R reads data or whenever you make an object in R stores everything in RAM. This can be, if you're working with a lot of large data files, this can be prohibitive. If you're, because if your computer's RAM, if you have, say, have 4 gigabytes of RAM and you're running Windows and you've got Chrome open, you're not going to have a lot of RAM left for data. Okay, so just be aware if you're working on a computer that doesn't have a lot of RAM, you can quickly run out of resources if you're working with large data files. This shows everything that is currently loaded in your environment. It has a bunch of other things that you can see as well. There's a history tab that shows you all of the things that you've typed in recently. It has connections, so you can connect to databases. It has an interface with GitHub, so you can integrate with GitHub. I've got a video that I can share that there's an introduction to GitHub if you all want to see that. And then it's got a series of tutorials here that walk you through various aspects of using RStudio. And then finally, you have your file window. Again, this shows you all of the files in your current working directory. So here, you can peruse different files that live on your computer, open up data sets, open up code files. It's just a way to interact with the local file system. If I do any sort of plotting, it's automatically plot here. So let's do a histogram of X. So the output of any graphical procedures automatically pops up there. Packages tab shows you all of the currently installed packages that you have. I have a lot. When you start out, you'll have probably a dozen that come with your base R, and as you install them, they'll populate more and more. There's a very rich help system that you can search for help on any function in any package. There's a viewer. Sometimes output will be interactive in this viewer. And likewise, you can also write presentations like PowerPoints in R that will show up down here as well. So there's a lot going on here. I highly recommend that there are a series of cheat sheets that come with RStudio on various aspects of the program. So there's an RStudio cheat sheet. There's various cheat sheets for other packages that come along. These are very helpful documents. So here's the one for the RStudio IDE. Again, it shows you a lot of different details of what I just talked about, but in much more detail, sort of where things are, what they do, et cetera, et cetera. Again, this is written by the community of people that wrote the software. So again, it's compiled a bunch of questions from a bunch of users, and it's made this as very commonly used or common questions that exist about the software. So I highly recommend checking out the various cheat sheets. I think we've said all this. Okay. Okay. So it's time for a quick break, or if people have questions right now, I'm more than happy to answer questions. We haven't been going that long, so I'm more than happy to just power through if you want to. Does anybody have any questions about the RStudio IDE or anything that we talked about so far? Again, this is just getting the software on your computer, which is a hurdle for some people. So I wanted to cover that. Okay. So if there's no questions, then we'll just power through. Okay. So one of the biggest issues that people have when they first start using R is that you might have used SPSS or something else. Toby, there won't be any changes really. When they change the POSIT, it's just going to be easier to work across code types. R is not going anywhere. So you have data from some other source, an Excel spreadsheet document, a comma separated value file, a SPSS data file, some data from somewhere else that you might have worked with in the past. or your professor tells you to download data from some source, and whatever data format it's stored in, how do I get that into R? And the answer is it depends on what type of data data format the data are stored in. But R has a series of functions in it that will read practically any data connection that you have. SQL databases are fine. It can connect to a lot of different database systems. It can read every format of flat file that you can come across. A good way to start working with different data file types is when you're using the file pane, it's actually very easy to open existing data files. So I'll go to a data file that I have on my computer. So here is it's a big one. Let's find a smaller one. So here is a data file that is a comma separated value file. Here's a data file. This is even better. This is a data file that's stored in a Stata format. So somebody made this in Stata, saved it as a .dta file. I can just go here and click on the file and hit import dataset, and R will generate the code and actually generate a little preview of what it thinks the file looks like. This is fantastic. I can browse around to see sort of what, if the data are look okay. This has done some weird things because it's automatically coding countries as numeric, which isn't right. So that might not be what I want to do. Here's one that's a CSV, comma separated value file, import dataset. This has got everything coded correctly. Again, it generates the code for you if you wanted to save the code to a file later. So I'm not a big fan of clicking buttons. Okay, and a big reason why I teach people how to use R and write syntax is to get away from clicking buttons. Because what happens if you forget what button to click, or if they change the software and the button's in a different place? Well, you could be lost. But if I have my code, the code is always going to do the same thing. Okay, so I can save the code in a code file, and it will always be repeatable. Which that's a big mantra in the R world is repeatable or reproducible research. So can I go back in a year, run my code and redo my analysis and reproduce all the results? Or can I go to Scott's dissertation analysis, run his code and get the same numbers as he did in his dissertation? These are huge things that sort of modern science is at a crisis with, that as research becomes less and less reproducible, you start having a lot of problems with people believing what you're doing. So writing code is a good start to making your analysis reproducible, not just for your sake, but for the people that come after you. So this is a great way to read in data. You can hit import. It will load it in and automatically pull it up for you in a new tab. You can browse the data. This is a bunch of demographic data from the Population Reference Bureau. It's several years of the World Population Data Sheet, which is a very popular demographic summary measures for every country in the world. And it gives you a little bit of output down here. Here's the code it ran in order to read the data in. It gives you a little bit of output about column specifications, and it uses this view command to actually load it so you can see it. So there's a package called Haven, which we'll install tomorrow. Okay, we haven't installed that yet. Doesn't come with base R. We'll talk about installing packages tomorrow. But it has functions in it to read data from all major statistical software packages. So there's this function read SAS to read a SAS data set. There are likewise functions to read SPSS files. So if you've got a .sav file, it's an SPSS data set, you can read that in. If you've got a Stata file, it's a DTA, it'll read all these things in using the appropriate function call. All you have to do is specify the path to where the file is located, and it will read it just fine. one thing that I do a lot is instead of storing data locally on my computer, I will read data directly from web sources. And so this is nice because R, you can give it a URL address and it will read file directly from the web. So this is a file that lives on my GitHub site. Which one is this? R courses. It lives in this website, R courses, it's PRB, 2018 World Population Initiative. 2018. So here's the data file right here. It lives on the web. This it's just text. This is the URL for that data file. So all I have to do is copy that URL and tell R that I'm going to read a CSV file because it's a comma separated value file, and I give it a URL. This URL function tells R that this quoted string here is a web address. It will read it directly in to R on the fly, so we can just we'll go over. Let me see, find this GitHub recent file. Is code. So all I have to do is go down here. I can run this code. It will read the data in, and I've got this PRB data file here in my environment. I can click on it and browse the data. Okay, it read it directly off the web, and you get this works with any type of format of data. So it can be a SAS file that lives on, say, a CDC website, or it can be a Stata file that lives somewhere on Bureau of Labor Statistics, and you can read it directly from that source directly into R. If you store the file locally, of course, you would just provide the path to the folder location where you store your data. And it all depends on where you put it on your computer as to what that looks like. Once you read the data in, you're going to naturally sort of look at it and poke around at it. And so an easy function to get started with is just the head function. The head function will view the first 6 lines of the data frame. Dustin, yes, the package readr is in tidyverse, and we'll install that tomorrow. So the head function will read the first, by default, it'll read the first 6 lines or display the first 6 lines of the file by default. We can change that. So let's say we wanted to do n equals 20 and show the first 20 lines of data versus the first 6. We can change that if we want to show more lines of data. And by default, this is what you're going to see. It's just all the variables in the data frame and the data set, first 6 rows. There's likewise a function called tail that will print the last 6 rows by default, and just again, so you can look at the data. You know, when you're getting a new data set or somebody's giving you something that you haven't seen before, you have to look at it. You have to browse it around it and explore it. And you know, one big thing that you're going to be looking for is, are data formatted correctly? Do variables look like? Did they use like a weird missing data indicator? Data sets will constantly do that. People that make data a lot of times. So what we have here, for instance, where is one? So R represents missing values with this code here is NA. Okay, SAS stores missing values as a dot. Various other softwares store missing values in different ways. A lot of times when you get data from a separate source, they may have generated a different type of missing data code. They may have code missing data as like -9. Okay, it may be an unrealistic value that you haven't that doesn't exist naturally in this variable, and so they'll use some odd value to code missingness. You have to read through the documentation of your data that you're using to learn about what these are. But again, you have to sort of look around your data to see what these things are. And you can visually look at it, but when your data starts getting in the hundreds and the thousands and the millions of records, looking around at things starts to become a little bit more laborious. So we're going to be looking at various summary functions tonight to help us do that type of work. So if we just take a look at various summaries of the data, there's a few different easy functions that we can use to get information about our data very easily. R stores data in its natural sense in something called a data frame. So you'll read data in from an external source, and it's stored as something called a data frame. You can think of this as much like an Excel spreadsheet. Okay, these two data files that I have open here, these are data frames. It's just R's sort of default way that it stores data. R has other more complicated ways it stores data, but this is the traditional sort of rows and column storage pattern that you're probably used to from spreadsheet land. Data frames can store any type of data, but most commonly they're going to store a mixture of character and numeric data. So R has a few different variable types, and it determines how it stores the information in a variable. Like before, when I tried to read in this stata file, where was that? Stata file. Yeah, here's a stata file. So when I try to import this stata file, you'll see here it has this column country, and it's numeric. So what it's done is it's taken the way that Stata wrote the file out and converted all those character values for the country labels into numbers. Okay, which is totally useless to us because what is country 1, what is country 2? We have no idea. Stata usually stores something, the data label something called a dictionary, which is the secondary file that stores the formats of and the labels of all the variable types. If that's missing, then all of your character formatting of all your numbers has been stripped and lost. So it's not very useful. So when we have our data frame open here, it's really easy to go around and browse. That's great. The first thing we're going to look at is what are the variables in the data set? What are their names? And so the function that you'll use to see what the columns are called, the column headers, is the names function. It will print out a list of all the different names of all the variables that are stored in the data set. Again, so this is this is one of the first things I do when I load a new data set in. I look at what the variable names are, because how am I going to work with the variables in the data unless I know what things are called? And oftentimes you'll have to use the documentation for your data in conjunction with your actual data on your computer to see, okay, what does E65 male mean? What is that? It's a label here. That's the column label, but what does it actually mean in terms of real world language? What does E65 male actually represent? You'll have to go to your documentation for your data to learn what that is. Most data come with a code book that come from a reputable source. There's a few different ways in which you can access variables within a data frame. The customary method is the $sign operator. So for example, if I use this head function again that we saw before, just to print out the first 6 observations, if I do head and I do PRB $, country is a name, it's the 3rd variable in the data set, it will print out the first 6 observations of the country variable, which are these 6 countries, okay? This is a general notation. A lot of times when you're doing a single operation, a single function on a single variable, you'll use this. Like let's say you want to take the mean of the infant mortality rate. Okay, there'll be a function mean. You name the variable that you want, and it'll do the operation on it. There's more than one way to do this, of course. There are these subset operators that you'll see a lot of people using, especially when you're writing code. So if I'll do this exact same thing. I want to get the first 6 observations of the country variable. but I can write it like this instead. These brackets will delineate subsets of the data. You can specify rows to the left of this comma, and then column names to the right of it, and this will extract the column that's named country from the data and print the first 6 rows again. Yeah. Okay. So doing more summary type of analysis of these of data frames is really useful. This is, again, one of the most commonly used functions that I use when I'm looking at a new data source, primarily because I want to see a summary measure of what's in each variable. Okay, and this is going to provide us a series of information that's really useful. It's going to provide numeric summaries for numeric variables. If you have variables that are stored as characters or factors, these will show frequency tables of those variables. So you get a lot of information out of this with just a simple function call. So for example, the region variable is, if I do a summary of it, it's just a character. So it's not going to print out all the different labels of every region in the data. All it tells me is that it's a character class. It doesn't give me anything else, okay? But if I tell R, okay, give me a summary, if I change this to a factor, it encodes the data differently. It encodes the data with, and it really adds the labels to the data then, so then you can see that it's not just, our processes the text better if it's stored as a factor, and you can use it more, you can use it better in other functions. So if I do as factor of the continent variable and then do a summary, you'll see it prints out a frequency table. So this is the number of countries in the data from each continent. For numeric variables, it will return what's known as a 5-number summary. 5-number summary is the minimum, maximum, first, second, and third quartile, and the mean. So it's 5-number summary of those things, and then the mean is added additionally. Plus, it will also tell you how many missing values there are in a given variable. So this is the percentage of women in the country that are using modern contraception, okay? So the lowest value is 2% of the female population using modern contraception across the world, okay? The maximum is 84%. The average is about 43%. You see the various quartiles of the distribution here. But there are 46 observations that were missing. So there's 46 countries out of about 180 some odd that are in the data that do not have an estimate of this variable. Okay. So this is a problem. You know, there's missing data in the variable. This could be a problem. We can talk about that in a different time. Again, I find this extremely useful when I'm looking at a new data set, because one thing I'm going to be using this for is to see, is there a variation in the actual values? Because if the data are coded strangely, or whoever was collecting the data made a mistake, it might say, if you think something's numeric and you do a summary of it and it's been coded somehow as character, then that's a problem, because you can't do data analysis or statistics on characters. You have to have numeric data usually. So this might be, well, somebody stored, a lot of times what happens is when people store data, they'll have weird characters in the data themselves. And when you go and read it in, as soon as R sees a character in any column, it's going to convert the whole column to a character format. And that can really ruin your day. But that's why doing this summary function is really great, because again, you see what it automatically shows you what variables the formats are. If they're numeric, it shows you the numeric breakdown of it. So just a really useful function in basic R. This is not the only way to do this. Other packages have other summary functions that do more thorough descriptions and add more flavor to things. So for example, the psych package, which is a package written by psychology researchers, it has the describe function within it that does a different type of description. The HMIS package is a package written by a biostats professor at Vanderbilt, Frank Harrell. Again, it's his the way he likes to describe data. There's a package called Skimmer, which has a skim function in it. All of these provide different, they usually provide the same type of numeric summaries, but they just output it slightly different. So for example, if we run this describe function in the psych package on our data, it's going to print it out like this. It gives you the variable number. So this is the variable name, the variable number, the number of cases, the mean, standard deviation, median, numeric summary, skewness, kurtosis, standard error, all these great things. And it does it for every variable in the data set. So there's quite a few. There's 27 different variables in the data, and these are all the summaries. So the n here is actually the non-missing n in the data. So this is useful for showing the valid number of observations. Skimmer is a slightly different output of its numeric summaries. Again, it prints the name of the data, the number of rows and columns, the number of character variables, the number of numeric variables, and then it goes and does a very similar breakdown of, first it'll do a summary of the character variables, number of unique ones, missings, completes, then it'll do the numeric summary of all the variables. And it's kind of neat because at the end over here, it actually does a little text-based histogram of the numeric values of the variable. So this is quite a bit for a single simple function. You get all of your summary statistics, you get your percent complete, you get your number missing, and plus you get the overall distribution of the variable in one little function call. So there's a lot here. Very common if you're dealing a lot with categorical or character factor types of data. The classic way that you would summarize it is using a frequency table. There's a lot of different ways to do this in R, but the basic function is called table. It will count up the number of observations of a different levels of a character variable. There's more sophisticated construction allowed in the X tabs. This is a great way to count up different combinations of your data. I use this a lot to generate frequencies by certain characteristics of respondents in a survey, for example. If you just use table and you can feed this, if this is a table is kind of dumb. It doesn't really care what's in there. It'll do a table of it anyway. So remember our variable x here. If I do a table of x, it's still going to count up the number of uniquely occurring values of that variable. And these are random normal deviates, so they're all unique. So it's kind of silly, but it's counting them all up. You know, it's not really very useful. But table will give you a frequency table of whatever you tell it to. Here, if I tell it to give me a table of the continent variable, it's going to count up the number of countries in each continent in the data. It can do multi-way frequency tables. So, for example, if I wanted to do table PRB $ continent, and let's say I wanted to make PRB $, if I want to do one that's life expectancy. Male life expectancy, let's say greater than 60. So this is actually kind of neat because R is going to first count up by continent, and then it's going to count up the number of countries in each continent that have life expectancies greater than 60. When R sees this type of comparison, it's going to evaluate as true or false. So if a given country's life expectancy is greater than 60, it's going to evaluate to true. If it's less than 60, it's going to evaluate to false. So you can see in African nations, 26 of the about 60 or 57 countries have life expectancies for men below 60 years, while 31 have at least 60 years or more. So this is a great way to break down. You can use multiple variables in a table. Once you start getting past about 3 variables in a table, it starts to become harder to see things. And so there are better ways to view that that we can talk about later. Measures of central tendency, so a lot of sort of basic analysis that you're going to be doing when you start reading in and doing summaries of your data, means and medians and standard deviations. Those are all really easily done in R. Of course, if I want to take a mean of a variable, mean of a single variable, I can just use my $ notation here and wrap it in the mean function. Okay. Mean PRB $TFR. And I get the average fertility rate, number of children per woman in the world in that year. Okay. If you have a variable that has missing values in it, let's say this variable here, GNI GDP is the gross gross domestic product. Okay, or it's the per capita gross domestic product. Let's try that. Mean PRB $G. Try to take the mean of it, and I get an error. Well, it's not really an error, but it prints NA. That's because this variable has values in it that are missing. It has a bunch of countries that do not have a GDP per capita measure. So, we would know this if we had done a summary of PRB $GNI. It'll tell us that there's 21 missing values in the in the variable. If I have a variable that has missing values in it, R is going to automatically not return the result. You have to tell it to allow there to be missing values in the function. This allows R to remove missing values prior to doing the calculation. Then it will report the mean. And this is the same value that's returned by the summary function here. Okay. So if you're trying to do this on your data and you see this NA produce, most standard sort of univariate statistical functions, mean, variance, standard deviation, median, if there's missing sums, if there's missing values in a variable, it won't calculate it because it can't use information in a missing value. It doesn't throw it out automatically, though. A lot of statistical software will automatically do what's called listwise deletion and remove any observations on the fly. Or you have to tell it a lot of times to remove missing values first. Okay. Yeah, I just said that. It's that. Median is also this is the median fertility rate versus the mean, different measures of central tendency. Measures of variation, standard deviation, things like that. There's this, I mentioned this 5-number summary before. There's a function 5num that produces this. It doesn't label anything very nicely, which is kind of a bummer. But again, it's going to produce what's known as the 5-number summary, which is the minimum, lower quartile, median, upper quartile, and maximum. It's very similar to what's produced by the summary function, 1, 1.6, 2.3, 3.8, and 7.2. 5-number summary doesn't include the mean, though. Okay. So this just is some basic ways to summarize data in R, some basic ways to read data into R. And there's a lot of these handy little functions that I use all the time, and I have for 20 years. I mean, these are things that I sort of learned very, very early on and carry them forward in every day when I work with R. If you're so is this all R will do? Absolutely not. R will do so much, and so this boot camp isn't a catch-all. It's not going to be everything R will do. It's intended to give you just a taste of what R will do. And tomorrow, in tomorrow's session, we will go a lot more in depth with some modern programming tools for graphing and doing numeric summaries and data summaries using the tidyverse, and go a lot more in depth. But these are things that I was working on a big new data file today. I was using these things. They're very core tools that you see in a variety of different workflows across R. I'm pretty much constantly amazed by things that are coming out in the R world. So many different things that that didn't exist when I first started learning R are now available, and so many more things coming out every single day. I've quickly been outstripped by the amount of new packages out there. I can't keep up with all of them, but there are so many different things out there that you can use to do wonderful analysis with. So to summarize for tonight, we covered some very basic concepts. You should be able to install R on your computer, get that up and going. You can follow the notes along to read the data in that I read in tonight, and do some basic numeric summaries of it, look at it, view it, summarize it. And then what we're going to do tomorrow, but these are all things that you'll do every single day. A lot of people ask sort of how to get good at using R, and you have to use R every single day. If you write code in R and do histograms and means and variances every single day and make it a core part of your research, you will learn a lot very quickly. Sometimes you'll run into headaches. My students will quickly answer, what do I do? And I have something in R that I can't figure out. What do? I Google it, right? I have so many Google searches bookmarked in my browser history that are just things that I can never remember how to do. And but I bookmark it. Like places like Stack Exchange, Stack Overflow, Twitter. A lot of bloggers out there write about R. There are different people that show you how to do things just for the sake of showing people how to do things. It's a wonderful, supportive environment that I've said this about before. As you start using R in your daily workflows or doing your research, your knowledge and your capacity for doing stuff will just expand every single day. But you do need to have, you do need to interact with it. You can't let it sit for 6 weeks, right? If you let it sit for 6 weeks and not use R for a while, your brain is going to fog up again, and you're going to forget how to do things. I went on vacation, right, for a week, and I came back and I hadn't wrote R code, and I was rusty. It just goes. A lot of times I just get up and I start working on it when I first get up in the morning, and if I don't do that for a few days, you lose your mental edge. So I would encourage you, if you're new to R, to start to work on a data project. If you need data for something, I'm more than happy to find you data on something that you're interested in. This is the student's number one lament is, how do I start doing this if I don't have any data? There are so many free data sets in the world that exist, so many different sources of information that you can get for free that will help you learn how to code and do data analysis in R. It's absolutely wonderful, the amount of stuff that's out there. If I can ever be of help, please let me know. All the materials for tonight are on my GitHub site. They're in the code file here, and you have both. This is today's, and this is tomorrow's. Day 1, day 2. HTML is this document that I'm actually looking at here. The QMD file is a Quarto markdown file, which is this document here. Basically has all the code to do all the analysis and make the formatted document, which has a bunch of stuff in it that we're not going to talk about tonight or tomorrow. You can write entire papers in R, and using things like Quarto, you can include your bibliography, have it format all that, include all your figures, include all that in a single document. It's really a nice way to go about writing. I do all my slides for all my classes in this, and it's a great way to produce a formatted document. And it's also cool because all the code, if you open the file from the chat, all the code up here at the very top, if you press this code button, all the code for all the notes is embedded in the document itself. So you don't have to have the original source file. All the code is embedded automatically in the document. So this is really cool. It's a great way to see sort of under the hood. Well, how did he do that? How did he include this image in the document like that? Well, it's part of using this this formatting language. Okay, so tomorrow we'll pick up again. We'll have, I encourage you to either spend some time tonight going through what we've done. If you have data that you've used before, try to read it into R. If you have trouble, I'm more than happy to answer email about this. Tomorrow, we're going to do a lot more sort of very practical types of data analysis stuff. We're going to see how to do a lot of different types of plotting. We're going to do a lot of different data summaries and data management functions and dplyr, and then look at some more things about installing packages, different R file types, a lot of more sort of core knowledge that's often skipped over. So I'm going to stop sharing now. If there's